Hi all, good day everyone. Welcome to the part 2 of automatic differentiation. My name is Raju Gopal. In this part 2, I want to suggest only one thing. Okay, so I want to suggest only one thing. Okay, so first, any operation we have to make a computational graphs. Okay, this is you will know how do we do that computational graph. But any operations, okay, any mathematical any mathematical operation or equations, okay, are the functions, okay, are the functions, okay, so we can convert to the computational graph, okay, computational, okay, computational graph, okay. So in the computational graph, okay, so we can convert anything into a computational graph. So in this computational graph, okay, so the representation of computational graph have only a three kind of operational nodes. Okay, one is the multiplication or division. Okay, this is the just opposite of this one. Okay, so next one is the addition or subtraction. This is the just opposite of this one. Okay, and then any other functions. Okay, some tan h r e power x something, any kind of functions. Okay, so only three kinds of operation nodes will come. One is multiplication, second one is addition or subtraction, third one is the any function. Okay, so now we can, so if you see all this methodology, by seeing this methodology we can derive a thumb rule. Okay, so we can derive a thumb rule. So if for multiplication, so we can derive a thumb rule. If there is a multiplication, automatically this gradient is equal to the, so because multiplication means we must use only a two, what I say, two inputs. Okay, so addition also we must use a two input. Okay, this is not going to, this is not less than 2 or greater than 2, it always equal to 2 in subtraction, in multiplication. So any this operation, if you use any function, there is only one input and only one output. Okay, so if you use a function, any one input one output. So if you already we have seen, so by applying the chain rule, we can calculate the what is the dl by dd. So dl by dd, dl by dl, okay, so dl by dl and dl by dd, this way we can calculate. This is nothing but the previous gradient. Okay, this is the previous gradient. This is one, dl by dd is nothing but the f. Okay, so f is nothing but the other node. Okay, f is nothing but the other node. So the function is the multiplication, the gradient is passing here. Okay, the gradient is passing here and the multiplication of other node. Okay, multiplication of other node. Okay, so how this affect? Okay, so if the effect of dl by dd is depend on whatever the gradient passing by the gradient from the previous node. Okay, gradient from the previous node and the value of other node. Okay, so if the value of other node is very high, this, if you change d, automatically the effect of the last function, okay, so very high. Okay, so if you change, okay, so this way we can, and we can judge. Okay, this way we can judge. Okay, so this will multiply. Okay, so this will the gradient, so if the operator is the multiplication, so this will multiply. Same way we will see the addition. Okay, here this is the addition. Okay, so if you see addition, okay, so if you see addition, so here this is that d, so this is the d is nothing but c plus e. Okay, so we can say dl by dd equal to, okay, so we can say dl by d, we can write here. Okay, we can write here. So here we can write dl by de equal to, okay, So already we have calculated. So already we have calculated. This gradient is nothing but dl by dd. Okay. So already we have calculated dl by dd into dd by de. Okay. This is equal to automatically. This is equal to this will cancel. Okay. dl by de. Okay. dl by de. Okay, so dl by d we will get here dl by de. Okay, dl by de. Okay, so if you use dl by de, so okay, so already we know dl by dd value, we know dd by, so now we can write, so dl by dd is the gradient. Okay, gradient, and dd by de. Okay, dd by de, d is equal to c plus e. Okay, dd by de is equal to always 1. Okay, so if you use any, so if it is the addition means always what will we get, this is should be 1. If it is a negative means we will get the negative 1. Okay, just to, okay, so if it is the addition, if it is the addition, or if it is the, what is it, if it is the subtraction, if it is addition or subtraction, so always we have to use this sign, and we have to just this gradient is passing here. Okay, so this effect also same effect. Okay, so this is, so okay, if you d whatever the effect we will give the dl by dd, the same effect also here. Okay, the same effect dl by d also give the same effect. Okay, so if it is the addition, okay, so if it is the addition, okay, okay, suppose it, okay, so if it is the addition, okay, suppose this is the, okay, suppose this is the subtraction means the other node will kill the negative effect. Okay, so this will, so this will automatically, this way this will give the -1. Okay, this will give the -1. Okay, so uh, so this way, so if it is the addition, this gradient is passed here gracefully without any change. Okay, without any change, just to multiply by 1. Okay, just to multiply 1 by 1, this passing here, same gradient will pass here. Okay, again multiplication, so again multiplication means this same gradient will, this same gradient will come here with the multiplication of this data value, gradient into this gradient, this data value, this data value, this and this gradient. Okay, so this way, so we can see, simply we can show, so this is the automatic differentiation. Okay, this simple only, these only 3 rules. Okay, only 3 rules. Okay, we can say 3 rules of the automatic difference. So entire network backpropagation is calculated by simply these 3 rules. Okay, so so if it is the, okay, if it is the gradient of, okay, what I say, if it is a any function, okay, if it is a one function, okay, so if it is a one function means, okay, 1 to 1, it is always a 1 to 1. Okay, so this is always a 1 to 1 means already we have calculated dly. So this is, if you see c, this is b, this is a, means already we have calculated dl by dc. Okay, so now we have to calculate dl by da. So okay, dl by da is nothing but, okay, so dl by da, now we have to calculate the dl by da. So this is nothing but the function of wait 1 second. Yeah. Okay, so now, so we will take this kind of network. Okay, so we will take this kind of network, and we will take this kind of network. Okay, so if you see, so this is the x. Okay, f x. Okay, x is the one input. Okay, so f of x, okay, this is our operation. Okay, so this will give the y, and that will, it will go to the l. Okay, so this way, so here already we have calculated dl by dy. Okay, so now we need to calculate dl by dx. Okay, so this is, okay, dl by dx. Okay, so now we have to calculate dl by dx. If you use a chain rule, dl by dx equal to dl by dy into dy by dx. Okay, dy by dx. So automatically, so straightforward, we can get dl by dy already we know. This is that our output node. Okay, this is our output node. Dy by dx is what is that? What is that? That operational node, differential function of operational node. So if you use the tan x means tan h means, so what is the differentiation of tan h? Okay, so if you use the e power x means, so what is the differentiation function of e power x? So in this way we will get what I say, we will get the dl by dx. Okay, so if you use any functions other than multiplication, division, or subtraction, additions, okay, that node always get only one input in our computational graph. Okay, in our computational graph, so there we will get, okay, so there, so we can say, so if we can define a thumb rule. Okay, so if you use the node is the functional node, okay, the node is the functional node. Okay, so we can say that this x, okay, the back propagate to the next node is nothing but whatever the differentiation of that function. Okay, that differentiation of function into gradient of previous node. Okay, into the gradient of previous node. Okay, so this value, okay, this value highly depend upon the multiplication of, so here, so that only they have to take lot of care here. Okay, so if it is goes zero, any function goes zero automatically, then it will go 0 0 0 0 0. Okay, so it will go 0. Oh, then there is no gradient, will there will be no gradient, so then there will be there isn't any landing also. Okay, so this way, so the automatic differentiation is working. Okay, so I have taken, so this is my ultimate aim to this explain in this video. Okay, um okay, so next we will see, so this way, so now we have to calculate. Okay, so I will do some quick calculation. Okay, so already we have calculated, so we will go our, so and everything is implemented. Okay, uh, okay, back got called. Okay, shift enter. Okay, shift enter, you see, so the gradient is calculated. Okay, the gradient is calculated, and the gradient is, okay, this is the multiplication of these two, this is the multiplication already we have seen. We will see a big example. Okay, we will see a big example. So already this is the big example. Okay, so first we will stop. That's a very simple one. Okay, this is completely like a neural network. Okay, if you see, you can see here this one. Okay, first we will send the w1 x1 w2 x0. Okay, so here we will do a multiplication, x1 w1 x2 w2, then we will do a addition, then we will send it to a, this is the, these 1 2 3 4 operations. Okay, so these operations, okay, then 4 and 5. Okay, this is the, this, okay, computational, so this all will happen in a single node. Okay, this all will happen in a single node, but here this will, in computational graph, this will happen in a 5 1 2. So if you have only one only, what can we say, only two input. Okay, if you have a two input, okay, if you have a two input into the neuron. Okay, so two input into the neuron, so in computational graph, in the neural network graph, it will be a, we will seen as a single node, but in computational graph, if you see 1 2 3 4 5 operation. Okay, it will split that, it will, okay, it will separated into a 5 operations. Okay, so this way, so this will give a more understanding, so more understanding how the, how if you use that positive sign, how does it work. Okay, so if there is a multiplication, how does it work, if there is a function, how does it work. Okay, so we can see all these variations here. Okay, okay, so here, okay, so first we will see, first initially, so we have to initialize our gradient. Okay, we have to initialize. Okay, there are two functions are there. Okay, so if you see, this is the backward. Okay, so already we have seen, already we have explained all this many times. Okay, this is nothing but to flatten the nested, okay, nested data. How to flatten the nested data logic is implemented here. So already we have seen this value class in computational graph